Well, thanks very much, Tom, and the OpenGeoHub team for letting me introduce SURF to you. Before I get into what SURF is and what SURF does, I want to tell you a little bit about myself and what I do at SURF. Like most of you, I started out as an academic, but instead of I did my PhD actually in computational astrophysics before I moved to Earth observation. So I find it actually quite a difficult question. Is astronomy more fun and more important than Earth observation? I think they are equally nice to do. Yeah, as most of you would know, having an academic career is difficult to combine with a personal life. You have to move around for your postdoc. So at a certain point, I settled down in the Netherlands. I worked at ASCHON, Netherlands Institute for Space Research, as an atmospheric scientist for 6 years. And it's quite interesting that you can easily jump from one field into another that's actually topic-wise completely different. But having had like the programming background in Fortran and Python that comes back, the physics, the radiative transfer that comes back both in astrophysics and atmospheric modeling, there are a lot of overlap actually. So it was the transfer was not as hard as I would have imagined. It was a very nice time. I worked on a retrieval algorithm for methane for Tropomi. I'll tell a little bit about that later. And after that, I worked in software engineering for a while, both in academia and industry. But now I work at SURF, and yeah, what do I do there and what is SURF? So my role there is a research partnership lead and a data processing advisor. This means actually I work together with researchers on their projects that have something to do with data processing, mostly in the earth science domain. And why do we specifically focus on scientific domains at SURF? Because at SURF we are actually domain agnostic. We serve all of research. That's because we noticed that if you have the domain knowledge of a certain project, it's easier to communicate with researchers what their IT requirements are and to onboard them on our infrastructure. So I already said a few things like IT and infrastructure, so it gives you a hint of what we are and what we do. So we are an IT corporation for the Netherlands. A corporation means that we have members. So we are a member organization. So not a traditional company or research institute. We really work for our members. Our members are also actually our owners. So they set out our strategy, our roadmap, and our service portfolio is to serve our members. Our members are the research and education institutes in the Netherlands. So that is all the universities, all the research institutes, but also the university medical centers. Yeah, and the NWO, for example, is also part of our members. And SURF has a long history, so the abbreviation Stichting Universitaire Rekenfaciliteiten tells you that we started out as a computing facility, but actually there were multiple functions. So in the beginning, there were 3 separate organizations. You have the SURF Market and SURFnet. SURFnet is responsible for the internet network. So like EduRoam is delivered by SURF, and the network also between the Large Hadron Collider and the Netherlands, where we store some of the data there. We also contribute to that. And SURF Market is more about contracting and IT licenses that we do for our members. So they join our forces so we can go to like a commercial company and negotiate better contracts for our members. But what I'm be telling you about today is more about the data and compute part of SURF, which is more the core for research. So we have over 100 members. If you're from the Netherlands, you would recognize most of these logos. But it does not mean that we are only doing national projects. We are also very much engaged in international, especially European projects, because you cannot do these kind of things in isolation, of course. I keep going there, but I need to go here. Yeah. Yeah, so this one. So our mission is actually to make sure that our members have the most innovative, best IT facilities so they can excel in what they do best, and that's the research and education, and not to worry too much about the IT part. And we do this together with them because, yeah, for example, we host a national supercomputer, but now we already need to think about the next generation. What do we have to purchase and what kind of system do we need to put there? And we cannot do this unless we know what the research needs in like 5 to 10 years, not only what they need now. And you know, innovation in this area goes so fast. So that's why we are building an ecosystem to do this together. So we have actually 3 roles. So not only as a service provider, so the traditional deliverer of data and compute services, of course, that's a big part of what people know us for, but we also are an association where we like do things together with our members in events, give trainings, yeah, and hope to share the knowledge there. And like I said, the innovation part is very important as well, because we always have to keep innovating our services. So we have a lot of innovation projects together with researchers. Yeah, we have more than 50 services, so it's a bit too much to go over them, all of them. I just want to give some highlights. I think generally you can categorize our services in the data part, compute part, network part, identity and access management, contracting. So I want to highlight some of our most used services. So we have the data archive, which is meant to for data preservation. So to store your long-term data for long-term that you're not actively using. So we use a cheaper form of storage for that. It's a tape library. We have a tape library on 2 different geographical locations, so that in some event happens, still your data is preserved somewhere else. Yeah, and there's a data management layer on top of this tape library, which we call the data archive. So these are really for big projects on a petabyte scale, I would say, to store data cheaper, but also more yeah, carbon neutral. So then we have Snellius, our supercomputer. These are mainly for very large-scale modeling, AI models. For example, weather models, climate models run there. And we have an event that we organize with our members every, I think, 2 or 3 years. It's a cyber crisis event. So we simulate cyber attacks, and then all the institutes that are involved, they will go through a scenario to see if they're actually prepared for such attacks. And they don't know the scenario beforehand, so it's a good exercise to, and quite important nowadays, to see if they are aware of the risks of, to the systems. SurfConnect is an access management system. It allows our students and researchers to sign in with only 1 login to different applications. So the universities can couple this also to their own applications. SurfDrive is a sync and share service comparable to Dropbox. All the staff at our member institutes, they get a free access to SurfDrive with some storage to it. And eduroam is, I guess, one of our most used services. It allows you to connect to the wireless of a different institute with your own host login. And it's now being used worldwide, but it was developed initially at SURF. And like I said, we also organize events to keep engaged with our communities, our users. So we have the research day for researchers. We have the we call it onderwijsdagen. It's education days for all the education professionals in the Netherlands to come together to talk on IT-related matters. Yeah, and our innovation project is perhaps most, well, at least the most interesting one from the hype perspective. So these are projects we start. Most of them are like short-term, but they can also be longer-term, together with researchers to experiment with some kind of innovative technology. One example is we are building a Dutch large language model. This is done together in a consortium together with TNO and the Dutch Forensic Institute. And we're only using open data for this. So it's also experimenting how that goes. How can you build a model that can compete with the commercial models in this way? And we're also dependent on data donors in this project. We have last year we did a big experiment testing the network connectivity between the Large Hadron Collider and our data center in Amsterdam. We store 10% of the data that's been generated by the Large Hadron Collider in Amsterdam together with NICHEF, which is the Institute for High Energy Particle Physics. And they are doing an upgrade in 5 years or so, which means that their data will increase with a factor 10. We have to test if the network is able to transfer all the data timely to our data center so that the researchers can process the data. So the first tests are quite positive, but also showed some bottlenecks in this infrastructure that then people can work on to be prepared in time for the Large Hadron Collider upgrade. We have the experimental technologies platform. It's this is a platform where we can together experiment on new kinds of hardware with researchers like accelerators, etc., but also with hybrid workflows, coupling quantum with HPC, for example. And that comes to the last example here, which is quite exciting. We've been granted funding to host the quantum computer in Amsterdam. So this is in process. It will be located next to our supercomputer, which will allow us to test hybrid workflows there. And this is being co-funded by the HPC program. So our milestones are in a lot of different areas. So indeed with logins, with having a lot of users using SurfDrive. It's just to show you some numbers there. So our activities are quite broad, but what do we specifically do for research, which is, I think, for this audience, most interesting? Like I said before, then it's more in the area of data and compute. You can divide it into research data management. This is a very upcoming important topic, also with the need for fair data. So it's not only good enough if you store your data, you also need to make it accessible, findable. So you need a research data management layer on top of that. and things like persistent identifiers. The large-scale computing is an important part of our portfolio. So the supercomputer, but not only the supercomputer, but also the high-throughput data processing. So in case you have a lot of satellite data that needs to go through your system, maybe not necessarily a large amount of cores. So that's a different requirement on our system. So we have a separate system for that. And the storage, of course, the data storage part. I think it's a bit too much to go through this in detail. The slide is there for people that are really interested in all the separate services and with their specific needs. I think roughly you can say it's high performance computing, data processing, or cloud computing. We have three different systems also for these three different flavor of computing. And that is because every research project is a bit different, has a different need. And this can also be sometimes confusing for our users. Why are there so many options? Why are there so many data storage options? It's just because there are so many requirements in your projects, and our infrastructure needs to be able to handle them all. But we're also looking into uniforming those services better. That's still also always work in progress. I'm gonna skip this one. So since that our service portfolio is so broad and it can be kind of complicated, so we also have advisors and people like me that interact with our user base and guide them through what they need for their project. So normally we do onboarding, whether it's for an individual researcher or a large consortium. We talk to them, we engage with them, and that makes us different than buying your compute and data from Amazon or whatever. So we really try to understand the problem and advise what fits best here. And also, of course, sometimes a commercial solution would fit your project better, and that's also possible. Could be a component of the solution, of course. You have to look at the entire problem, not only at what specific solutions are there. So how do researchers in the Netherlands, at least, get access to our services. So we are funded by, we are partly funded by NWO, this is the Netherlands Organization for Scientific Research. We are also funded by our members. They pay like, a member fee to be part of the corporation. And NWO funds the National Compute Call. So this is an open call for all researchers. They can write a small proposal and then get access to our systems. And we have the option to do this in a short proposal or longer proposal. But the idea is that if you write a short proposal, you can get on our system like within 2 weeks. So we want to make the threshold as low as possible that people can get on our systems quickly. But for larger projects, there's a more formal procedure, but that's when you need like over 1 million core hours. Yeah, so this is a bit of a summary of what I said through the call, and then we have we offer support through our service desk. Yeah. So I want to get into some examples of projects that we host on our systems, just to give you an idea how broad the spectrum is. Some I mentioned already. I think, yeah, so we work together with NICHEF and CERN to store and process the data for the Large Hadron Collider and other experiments that run there. So this is mainly done on the grid. The grid is like a clusters of computers located not only in the Netherlands, but worldwide. So that was actually came to existence to process the huge amount of data that this accelerator is generating. And we are part of this worldwide grid. It's also, this grid is also being used for other projects, like for LIGO Virgo that detect gravitational waves. There will be a future space mission, LISA, that will detect gravitational waves from space. And we're also in conversation of how to help process that data. Yeah, and the radio telescope at Astron also use the grid, and we also host their data on our tape libraries. I think on one project that's more targeted for this audience, and that has been mentioned before, is TROPOMI. So TROPOMI is an instrument measuring the atmospheric composition through observing the spectra. So looking at the absorption lines of certain molecules, you can invert your radiative transfer model and get an idea of what the atmospheric composition is. And this inverse modeling, this is algorithms developed by KNMI and Esron. They run also on our systems to analyze the data. And we help to set up the pipelines for this data processing on our systems. But it's not only natural and engineering sciences, it's also social sciences and life sciences and health. These are very upcoming domains that are increasingly needing IT infrastructure. So one interesting project we have is with social scientists that need to use CBS data, which is statistical data about everybody in the Netherlands. You can imagine that's highly confidential data, privacy sensitive. So we built a how do you call it, a secluded environment on our supercomputer where people cannot see the data, but they can still access it with models to do research on. So this opens up new opportunities for researchers to do research with data they otherwise are not allowed to touch by CBS. I think I will not go on all to them in detail, but feel free to talk to me later if you're interested. I think this is this. Yeah, I don't know. I have a little bit of time. I wanted to dive a little bit more into the details of TROPOMI, because this is a project I worked personally on for 6 years, and give you a bit more feeling of then how do we onboard such a project at SURF. So Topomi data processing is being done by ESA operationally, but the scientists at Esron, they wanted to have also like a scientific data processing pipeline where they can play with. So like change some parameters, change the algorithms, run the processing again, see what changes, so they can continually update their models. And this is not possible in operational environment like ESA, so that's why they came to SURF. At that time, actually, I was working at Esron, so I was on the other side of the story. And at SURF, the advisors helped us to migrate the pipelines on their systems. And it sounds easy, but it's actually, it means you have to like build an entirely different orchestration framework to do this. And this was really done in co-development with the SURF advisors back then. So for satellite data processing, there are always a few steps that you need to take. You have satellite data, you need to co-locate it with other auxiliary data like weather data or dam data. So this is called a pre-processing step. And then there's another processing step that goes, like calibration goes to level 1, and another step goes to level 2. So there are different steps and they're all kind of dependent on each other. And then you have to put this in kind of a framework that does this automatically. So you don't want to like start the scripts all manually. And I think this is a solution we currently have at SURF. Yeah, I'm not sure if I should go into this because it's very detailed, but I do find it very interesting. So come talk to me if you want to know more. But the idea is that you split the jobs that you want to process from the software and the models that you want to execute. So the databases store the jobs that you want to process, but then you set dummy scripts to a scheduler that actually grabs things from the database and then start processing. But all the information of where the software is and where the data is in the database. It's not in the jobs that you submit. The jobs that you submit are kind of like dummy jobs. We call them pilot jobs here. But this makes your pipelines quite more flexible and decouples like one researcher can like make jobs, but they don't need to know how the software works exactly. So this is a flexible system that we are using for more projects now. But I'm happy to talk more about this if anybody's interested. And this allows us as on researchers to do science they were not able to do with operational pipelines because they could like add new algorithms to it, add new products to it. So one of the products that was at first not in the operational data products is the HDO product, and that's being hosted by SURF. Yeah, and that's it for now. And yeah, if you have questions, I'm happy to answer them.